So here we're going to look at some linear homogeneous recurrence relations where, well, you're going to see they're going to be repeated roots, these examples. You look at the characteristic equations. We want to solve this one. What we got? An is negative 10 an minus 1 minus 25 an minus 2 for n greater than or equal to 2. We have two initial terms, a0 and a1. So the first thing to do is to set up your characteristic. Equation. This is going to be what we're talking about, degree 2 here. Right, from n to n minus 2, there's a distance of 2, so degree 2. So we're going to have a degree 2 polynomial. We're going to have r squared equals minus 10r minus 25. I'm going to add 10r to both sides and add 25 to both sides. I'm going to get r squared plus 10r plus 25 equals 0. If you were to factor that, make two pairs of parentheses, equals 0. Let's see, r times r gives me the r squared, and then now I got to find two numbers that multiply to give me 25. It's positive 25. And to give me 10, well, what? Positive 5 and positive 5 do the trick, right? Positive 5 times positive 5 is 25. Positive 5 plus positive 5 is 10. So we got what? R plus 5 quantity squared equals 0. That's a single factor repeated, right? It's a factor r plus 5 repeated. So I set my single factor equal to 0. And I get r equals minus 5, and this is a multiplicity 2. Why is it a multiplicity 2? Because it happened twice, right? Yeah, you see the square back there, right? The square back there. That guy right there, right? He's a multiplicity 2. Yeah. So it's two copies of that root. So now I want to write down the solution form, the form of the solution. So it's going to be a sub n is going to be, so we're going to have, this is just one root, alpha 1 comma 0 plus alpha 1 comma 1 n to the 1. And we're going to stop at n to the 1 power because the 1 power is 1 less than the multiplicity of 2. And then we're going to have a root negative 5 raised to the n power. So that's the form. Now, to complete this, to find the exact solution, you have to find these alphas. Alpha 1, 0, alpha 1, 1. How do I do that? Yeah, why not? Find alpha 1, 0 and alpha 1, 1. So we have to go back to our initial values. Alpha 0 is 3, alpha 1 is 5. I'm sorry, A0 is equal to 3. And A1 is equal to 5. I think that's right. Yeah. All right. So how am I going to do this? So basically what I'm going to do, I go back to my form. And in place of the n's, I'm going to put a 0. So when I put a 0 after alpha 1, 1, that's just going to 0 out. When I put a 0 above negative 5, I'm going to get just 1. So all that's going to be left is alpha 1, 0 here. So alpha 1, 0 is 3. All right. Now, I can apply 1, oops, my bad. I can plug in 1 into my a sub n in place of n. And when I do that, I'm going to have, let's see, alpha 1, 0 plus alpha 1, 1, right? I'm plugging in a 1 for n, then I'm going to have a parentheses around that, and then I'm going to have multiplied by negative 5, right? Multiplied by negative 5. Yeah, because we had negative 5 to the 1 power, right? We're plugging in that 1 for n. So I need to solve this for alpha 1, 1. So what do I have? I have what? Well, we already know alpha 1, 0 here. Alpha 1, 0, we already know this guy. Right, that guy we already know is 3. So we can write this as 3 plus alpha 1, 1 times negative 5 equals 5. And divide both sides by negative 5. If we divide both sides by negative 5, we got what? 3 plus alpha 1, 1 equals negative 1, right? Divide both sides by negative 5. 5 divided by negative 5 on the right is going to be negative 1. And then you can subtract 3 from both sides, and you get alpha 1, 1 equals what? Minus 4. So you have alpha 1, 0 is 3, which we had earlier. And alpha 1, 1 is 4. Those are our coefficients. Right, let's plug them in. 3 and minus 4. So here we go. Solution. It's the exact solution. A sub n equals 3 minus 4n, parentheses around that, minus 5 raised to the n power. That's it. Right. Do another one. Might as well, right? Might as well. Might as well. Let's see. That's just a single root that's repeated there. Okay. I'm going to scroll. This will be number 2. Number 2. Say we want to solve this. A sub n equals 6. A sub n minus 1. Minus 12. A sub n minus 1. Minus 8. This is 8. A sub n minus 2. Yeah. That should be a sub n minus 2. That should be a sub n minus 3. For n greater than or equal to 3. And we're going to be given a 0. It's negative 1. A1 is 4. A2 is minus 16. All right, let's do the characteristic equation first. And find its roots. What do we have? Degree 3, right? Why degree 3? Well, from n to the bottom, n minus 3, space 3. So we're going to have degree 3 polynomial. We're going to write what? R cubed equals 6r squared minus 12r minus 8. And we're going to subtract 6r squared from both sides. We're going to add 12r to both sides. We're going to add 8 to both sides. And on the right-hand side, when we do that, we're going to get 0. So we got r cubed minus 6r squared plus 12r plus 8 equals 0. So how to factor this? Well, there's a trick on this one. If you pay careful attention here. R cubed and plus 8 is a sum of cubes, right? Sum of cubes. So we can put those together. And the other is minus 6r squared plus 12r we can put together. So I'm going to put a highlighter here. So the yellow stuff, that is what's called a sum of cubes. So using the sum of cubes form for factoring, you have what? R plus 2 times r squared minus 2r plus 4. Now for the blue stuff, notice that you can actually factor here a minus 6r, right? Minus 6r. When I pull out a minus 6r, I'm going to be left with did I write this down right? I didn't write this down right. The original problem is written down incorrectly. There should be a minus right here. That's a problem. So that minus is going to make this a minus, which is going to make that a plus, which is going to make that a plus, which is going to make that a plus. So we factor out a 6r, and that's going to leave us with r plus 2. Now that's equal to 0. Now maybe you notice you have something in common. Here and here is something in common. You're going to have what? R plus 2 in common. So I got r plus 2 in common. I'm going to factor that out front, and I'm going to be left with something, and that's all equal to 0. What's the something? Well, it's a yellow r. That's supposed to be yellow, not red. Let's try that one more time. R squared minus 2r plus 4 plus 6r. If you combine these like terms right here, that's going to give you 4r. 4r. So we got, let's see, factoring this. R plus 2. R squared. So here we're combining our like terms. We're going to have 4r plus 4. All that's equal to 0. So we got r plus 2. And when we factor r squared plus 4r plus 4, that quadratic factor, make two pairs of parentheses equals 0. We're going to have what? An r times an r to get r squared. And then we're going to find two numbers that multiply to give you 4. And add to give you 4, namely positive 2 and positive 2. So r plus 2, r plus 2, r plus 2, the three factors that make up this third degree polynomial. In other words, what? R plus 2 to the third power equals 0. So you only have to set one of those equal to 0. That follows from the zero product property. If you have three things multiplied to give you 0, one of them has to be 0. So only r plus 2 has to be equal to 0. So r equals negative 2. And this has multiplicity 3 because it was repeated 3 times because you have that power of 3 right there. All right, so you have a single root that's repeated. 3 copies of that root, basically. So I suppose we should look at the form. Yeah, let's look at the form of the solution. The form of the solution is going to be what? A sub n. And we just have one root here. We're going to start with alpha 1, and then we're going to go sub 0 plus alpha 1. Sub 2, sub 1. You got to count up 0, 1, n to the 1 plus alpha sub 1 comma. Now we count up 2 and then n squared, and we stop at the square, right? Because the square is 1 less than the multiplicity 3. to stop there, and then you remember your root, which is -2 to the n power. All right, so that's the form of the solution. So what we have to do now, we got to find alpha 1. Zero, alpha 1, 1, and alpha 1, 2, right? That's what we want to do. So I'm going to write that somewhere. I'm going to scroll. Find alpha 1, 0, alpha 1, 1, and alpha 1, 2. Don't have room to do it, but I'll do it down here. Now, to do that, we gotta have our initial conditions. Totally forgot my initial conditions. Here they are. -1, 4, and -16, respectively. -1, 4, and 16. Say 0, A1, and A2 respectively. So what I'm going to do, I'm going to plug in 0 in place of n in the form of the solution. So I'm going to put a 0 here, a 0 here, and a 0 here. That's going to leave me with alpha 1, 0, just literally an alpha 1, 0. Okay, then I'm going to plug in for the next initial condition, a sub 1, I'm going to plug in n, a 1 in for n in the form. When I do that, let's say I'm going to have alpha 1, 0 plus alpha 1, 1 times 1, which is alpha 1, 1, plus alpha 1, 2 times 1 squared, which is alpha 1, 2, and that's going to be all multiplied here by -2 to the 1 power, which is -2. All right, so then I got to do the last initial condition, apply that. I'm going to plug a 2 in for the n's. When I do that, I'm going to have what? Alpha 1, 0 plus, I'm going to plug in 2 for n, I'm going to have 2 alpha 1, 1. Okay, plus I'm going to plug a 2 in for n, I'm going to get 2 squares, 4, so I'm going to have 4 alpha 1, 2. And then I got -2 squares, going to give me 4 there. All right, so I got one of the coefficients done. Go on. I have alpha 1, garbage. Shame, it's not working. Okay, so I got alpha 1, 0 is -1. All right, so we can plug that in here and here, highlighted areas. That'll give me 2 equations basically to deal with. So I'm going to have what? 1 plus alpha 1, 1 plus alpha 1, 2 times -2 equals 4. That's the second equation there. I plugged in 1 for alpha 1, 0. Oh, it's a -1, right? -1. And then in the next equation, I'm going to plug in a -1 for alpha 1, 0, so I have -1 plus 2 alpha 1, 1 plus 4 alpha 1, 2 times 4 equals 16. So we'll clean these up. See, we get -1 plus alpha 1, 1 plus alpha 1, 2. Divide both sides by -2, you get rid of -2 on the left. On the right, you get a -2. And for the second equation, -1 plus 2 alpha 1, 1 plus 4 alpha 1, 2 times 4. Divide both sides by 4, and you get -1 plus 2 alpha 1, 1 plus 4 alpha 1, 2. So when I divide the left side by 4, cancel the right side by 4, I get 16 divided by 4 is 4. Looks like we're going to have two equations and two unknowns. So I'm going to add 1 to both sides for each of those equations. We're going to get alpha 1, 1 plus alpha 1, 2 equals negative 1 when I add 1 to both sides. And the other equation, 2 alpha 1, 1 plus 4 alpha 1, 2. I add 1 to both sides, I get 5. If you want to, you can set up a little augmented matrix. I mean, you can solve it by hand, but I'm going to do quickly an augmented matrix. I'm going to do the entries. In the first column come from alpha 1, 1, so 1 and 2. Entries in the second column, which come from the coefficients of alpha 1, 2, so 1 and 4. I'm going to put a separation bar where the equal sign would go, and then on the right-hand side, I'm going to put negative 1 and 5. I'm going to reduce row echelon form that, RREF that. When I get there, I've done this somewhere, I think. Somewhere over the rainbow, way up high. Oh, I haven't done it somewhere. All right, time to do it. All right, second matrix. Edit. I do about 2 by what, 3? Yeah. 1, 2. 1, 4. Negative 1, 5. Yep. Second matrix. Math. RREF. 83, it's B. Second matrix. Enter. Yeah. So we get what? 1, 0, 0, 1. All right, it looks like 9 over 2. 7 over 5. 7 over 2, my bad. Yep, so your alpha, what was it called? 1, 1. It's 9 over 2. Your alpha, what was it? 1, 2. 7 over 2. And don't forget we had another coefficient. Alpha 1, 0 was negative 1. Alpha 1, 0 was negative 1. We did that, the highlighter back there. All right, so we got all these constants. Now we can actually write the exact solution. Where are we going to put the exact solution? I don't know, maybe I'll write it down here. Exact solution. I'll just write solution. Put it up. Going kind of like a violet kind of color. Solution. Come on, no, maybe not. Put a red. Red. This is going to be what? AN. So alpha 1, 0, that was negative 1 plus alpha 1, 1, what was that? 9 halves? 9 halves. Come on. Times. Dude, you can write if you want to. Plus alpha 1, 2 was 7 halves. N squared. And then you close the parentheses around that and negative 2 to the n power. That is, yeah, that's our solution. Cool.